This is our third lecture, isn't it?
Yes, ma'am.
Okay. So we were doing exercise number 9. Let's look at another question. Shall we start?
Yes, ma'am.
Okay. So this is your integration 0 to 1 inverse 1 minus x plus x squared dx. How do we deal with trigonometric inverse function? Remember? You integrate inverse function tan inverse of x dx.
By part integration by part got into like that.
Yes. What is your first function? What is your first function?
One. A first function 10 inverse x and one like
yes, very. We can write it this way: 1 into 10 inverse of x, and we say that this 10 inverse of x is your first function u, and this 1 is your second function v. Okay, so do you all remember? Okay, by parts, we will discuss it later. By parts rule. So this is how we deal with tan inverse, trigonometric inverse function. But here we also have trigonometric inverse, but there is one problem. We have its angle is very complicated, 1 minus x plus x square. Okay, so what are we going to do? We are going to simplify this expression first, and then we can apply that by parts rule. So how can we write this cot inverse of 1 minus x plus x square? You all remember your properties. So we can write it this way: tan inverse 1 over 1 minus x plus x square. This comes in denominator if we replace cot inverse by tan inverse. So this is it. Now what next? Can you tell me what changes we are going to make in this function now? Can anyone guide me?
Multiplying by 1 plus x by 1. 1 plus x.
1 plus x by 1. No. Can we write this whole expression like this? Okay, let's write this expression in this way. In numerator, can we write it as x plus 1 minus x, and in denominator we can write it like this. Observe it. What happened? 1 numerator doesn't change. We have just simply added x and subtracted x. And look at denominator. 1, we have taken minus x commons from here in this expression. We have taken minus x common, and you are left with 1 minus x. So what do you observe? What is this? Don't you think if we say x is a and this is b, then you got tan inverse a plus b upon 1 minus ab. What is it? Isn't it? We got it in this way, this form. What is this? Come on. Exactly. This is formula for tan inverse A plus tan inverse B. So now we have simplified our function. Okay. So if we can write this whole in this way, so we have now got desired integral. So this whole portion is clear to everyone? Any doubt anywhere? So we can write it this way. We can write it as tan inverse of integration from 0 to 1 tan inverse of x plus a is your x, you see, and b is your 1 minus x. So we can our another integral is 0 to 1 tan inverse a plus tan inverse b. What is your b? Your b is 1 minus x dx. Okay, so this is your a, this is your b. Tan inverse, we have written this integral as tan inverse a plus tan inverse b. Now what next? You all will take,
tan inverse 1 minus x पनि गराउन मिल्छ नि.
very good. Or we can make the second one as tan inverse of x, isn't it? Don't you think so?
Oh,
Yes, ma'am.
Exactly. So let's make it that way. Using properties of definite integral, using properties, or you can say with the help of property, using properties, we can write integration from 0 to 1 of tan inverse of x dx equal to 0 to 1 tan inverse of 1 minus x dx. So according to your properties of definite integral, both these integral are same, equal. Okay, so what does it mean? That in place of tan inverse x dx, we can write tan inverse of 1 minus x dx, and also in place of tan inverse of 1 minus x dx with limits of integration 0 to 1, we can write 0 to 1 tan inverse of x dx. Okay, so यसको ठाउँमा यो पनि लेख्न मिले, यसको ठाउँमा यो पनि लेख्न मिले, but the desired expression, हामीलाई कुन expression चाहियो? We want this expression. Okay, so let's change this one, second integral. Okay, so what are we going to do next step? In our next step, we can write it as, this also becomes same. You did the same boy, yo तिमीको same आयो. Okay, this, both these integral are same. So can we write it like this? 2 times 0 to 1 tan inverse of x dx. You do the integral same, sir. So let's write it this way, 2 times 0 to 1 tan inverse of x dx. Clear? Further you can do. Yes?
Yes, ma'am.
Okay, yes. Let's recall your by parts rule. Okay, so because you are going to use your by parts rule in this expression. So let's do that. We have already discussed that you are going to assume tan inverse of x as your first function. You will assume tan inverse of x as u, 1 as v. So let me tell you one thing. Let me guide you for one thing. While doing this, you may make one mistake. So let me help you with that. What do you see actually? What you have? You have definite integral 0 to 1 tan inverse of x dx. So when applying by parts rule, you have to keep this in mind that let's find out final expression after applying by parts, and then finally you will apply limits of integration. You have to apply limits of integration also. So don't apply limits of integration in between. So what will you do? You will first of all solve this indefinite integral. Okay, so let's solve this. What is the by parts rule? U v dx. If u and v are both for some function of x, u is your first function, v is your second function. So what is it? First function as it is, integration of second minus integration of differentiation of first function with respect to x into integration of second function with respect to x and whole dx. Okay, so this was your rule, by parts rule. Now let's apply this here. So your u is 1 tan inverse of x and v is 1. So let's apply it here. So integration of 1 into tan inverse of x dx. So this is your v, this is your u. So let's apply it. You will get what? Tan inverse of x, and integration of 1. Integration of 1 is multiplied by x minus integration of differentiation of, what is differentiation of tan inverse of x?
1 by 1
1 by
plus
1
by
plus
1
x
plus
square.
x square.
1 by 1 plus x square, and this, its integration will give you multiplied by x dx. So now you have to simply integrate this expression. So you all know how to integrate this. How do you integrate this?
1 by
1 by
2
2 ln 1 plus x square.
Yes,
square.
exactly.
Divided by
Yes,
2.
yes, yes. You can multiply it by 2, divide it by 2. So when you do this, what happens? That your numerator becomes derivative of denominator. I know. So numerator becomes derivative of denominator. So in this case, you can directly write it as 1 by 2 log 1 plus x square, derivative log of denominator. Okay. So Timer final expression kya honi bhai? What will be your final expression? Let me continue it here. Your final expression will be x times tan inverse of x minus 1 by 2 log 1 plus x square. So this is the final expression. What will you do now? Now it's the time that you apply your limits of integration. Finally, okay? So you are going to apply limits of integration at the end to avoid any mistakes. Okay, so you can solve it now. Apply your limits of integration and get the result. Okay, what is your result? Let me help you. Pi by 2 minus log 2. You must get pi by 2 minus log 2 as a result. Okay, clear to everyone? Any doubt anywhere?
Ma'am, isn't 2 missing in the first?
What is missing?
2.
Oh, yes, yes, yes. 2 times. Yes, 2 times also, definitely. I've just discussed. यो केसमा चाहिँ मैले यो एक्सप्रेसनलाई मात्रै सल्युसन डिसाइड गरेको. ओके, हाउ यु गो फर इट so that you don't make this apply when to apply limits of integration. I was just guiding you with that. You don't forget this 2. 2 is there obviously.
Okay, ma'am.
2 times of we have got the result, 2 times of that result. Okay, clear, Saba?
Yes, ma'am.
Yes, ma'am.
Yes, let's continue with another question. Now your question is 0 to pi x times of dx over a square sine square x plus b square cos square x. So for the time being, forget that you don't have that you have x in numerator. You assume that we don't have x in the numerator. You have simply 1. So if I ask you to integrate this, will you be able to integrate? What is your method of integration? Can you tell me?
तलमाथि स्क्वायरले मल्टिप्लाई गर्ने.
Yes, exactly. Yes, exactly. You will multiply numerator as well as denominator by. So what was your steps? Multiply numerator and denominator by sec square x. Then you will change everything in denominator. Denominator everything you will convert in terms of tan square or tan theta. You can 10x. You can say, and then what is your next assumption? You will assume 10x equals to t.
10x equals to t or something.
Yes, 10x equals to t. You will assume and then you will continue. Okay. So definitely in this case also you have to do that. But before doing that, we have to eliminate x first. हमले numerator but x eliminate गर्नु पर्यो. Now let's include x also. Now our problem lies here. We don't want this x in numerator. Okay. So how are we going to eliminate? Do you remember elimination of
x
x?
like pi minus x ले replace गर्ने.
Very good. Okay. So using property. Okay, so what are you going to do? You are going to use property. Using property, you can write whole this expression यो जुन expression छ यसलाई कसरी लेख्न मिल्यो
माथि पाइ x आउँछ अनि डिनोमिनेटरमा चाहिँ सबै सेम हुन्छ
Okay, so let us assume that this integral is equals to I. Let's say that this is equals to I. So your new I becomes, when you apply property, you will get pi minus x in numerator. Numerator ma timeko pi minus x आयो x को ठाउँमा. And in denominator also, wherever there is x, you will replace it by pi minus x. What are you going to get?
The
when you do that? What is sine square pi minus x?
cos square x.
Sin square.
It
Sin
remains
square
as
x
it is. It remains as it is. Isn't it? Sin pi minus x is sin x. हैन sin pi minus x तो sin x नै हुन्छ. So square गरेर के फरक पर्यो परेन sin square x नै रह्यो. Similarly, what is cos square pi minus x? What is cos pi minus x?
Minus cos x. Cos square x.
अब चाहिँ स्क्वायर गर्दाखेरि सेम रह्यो.
Yes, exactly. हैन because cos pi minus x is minus cos x. So you have a square. So minus minus plus. So you got again cos square x. So यो जुन denominator को expression छ त्यसमा के पनि change आएन. It remains as it is after applying property also. Okay, so replacing x by pi minus x, you got pi minus x upon same denominator. Okay, so now we can get rid of this x. Why? Because we can split this into two integrals. यसलाई दुईटा इन्टिग्रलमा डिवाइड गर्न पाए एउटामा न्युमरेटरमा पाइ आउँछ एउटामा चाहिँ न्युमरेटरमा x आउँछ. So you can write it this way. Let's say I equals 0 to pi times dx over first expression, same denominator, I'm just making a symbol, minus 0 to pi x dx over same denominator. So what is this? Isn't this I? Isn't this I?
Yes, ma'am.
I? यो त तिमीको I नै भयो. So you can take this I to the other side. You can take this I to the other side and you will get 2I equals 0 to pi 1 dx, sorry, not 1.
Pi.
Yeah, pi dx. This is your pi dx over a square sine square x plus b square cos square x. What next? Now we have to use that method which we have discussed above. I know, but before doing that, we want to change this expression. We don't want pi in your upper limit. Why? You will realize later. Kena pi like convert garna pare. Why? We have to make it pi by 2. We are going to make it pi by 2. How are we going to make it pi by 2? Can you tell me which property we are going to use?
त्यही त्यो f a minus twice x is equals to fx भयो भने twice times 0 pi by 2 सम्म हुन्छ भन्ने वाला.
6, yes, property number 6, 0 to 2a f of x dx is equals to 2 times this one. This one. Okay, 0 to 2a f of x dx is equals to 2 times 0 to a f of x dx if you remember this condition, f of 2a minus x is equals to f of x. So यो केसमा हामीले भर्खर हेरे न pi 2a is your pi. 2a pi हो त pi minus x गरेर त एक्सप्रेसन मा केही चेन्ज आएन हामीले भर्खर हेर्यो हैन डिनोमिनेटर as it is छ त तिमीको function remains as it is. That means it satisfies this condition, so we can convert it in this way. So we can change limits of integration from 0 to pi to 0 to pi by 2. Okay. So where were we? Here. Okay. So we are going to use property using property number 6. Okay, let me mention number also. Property number 6. Because why you can use this? Because here in this expression, because here your f of pi minus x is equal to f of x. तिमीको function में के change आएन? When you replace x by pi minus x, it remains as it is, I know. So we can use this property number 6, which says that this integral can be written as, according to this property, we can write this integral as 2 times 0. Yes, come on.
Pi by 2.
0 to pi by 2 pi times dx upon same denominator sine square x plus b square cos square x. Now it's the time that you apply that procedure. What you will do, you will multiply numerator and denominator by sec square x. Let me show you a few steps and make you realize why we changed our limits of integration. What is the reason behind this? Okay, so this 2 gets cancelled, your 2 cancel boy, and what are you going to get in next expression? You're going to get I equals 0 to pi by 2 sec square x in the numerator. Let's take this pi outside. Sec square x in the numerator, and in denominator a square sec square x is
A square sin square x is tan square x.
exactly. Plus b square cos square x into sec square x is
b square.
simply b square, right? So yes, dx also. Now it's the time that you make that substitution. We have already decided that our substitution will be 10x equal to t. Either you assume 10x equals to t, or you assume a 10x equals to bt, whatever, whichever is comfortable. यसरी assume गरे पनि हुन्छ. It is up to you. You will get same results. Result में केही फरक पर्दैन. So let's make it this way. A 10x equals to bt. So a, after differentiating, you will get a sec square x dx equals to b times of dt. Okay, so what is the new limits of integration now? What will be your limits of integration? Limits. Let's talk about limits now. Okay, so your first lower limit is 0. Put 0 here. What is 10 0? What is 10 0?
0, ma'am.
0. So your t comes out to be 0. Your lower limit is 0. So what is your upper limit? Your limit changes from 0 to
infinity.
Infinity, isn't it? 10 pi by 2 is infinity. So your t also becomes infinity. So upper limit becomes infinity. Now what? What if there is pi over here?
It will be
We'll
0
get 0
to
to 0.
Yes.
0 नै हुन्छ.
Yes, I know. So how come you have same limit of integration from 0 to 0? It doesn't make any sense. I know.
Yeah.
You are not going to get any result out of it. So that is the reason we changed limits of integration. Okay. So
0 देखि 0 भएको भए रिजल्ट 0 आएको जस्तो हुन्छ म्याम इन्टिग्रेसनको.
तिमीको त लिमिट अफ इन्टिग्रेसन लेखको नै मिलेन भन्न पर्यो हैन. हामीले लास्ट टाइम पनि डिस्कस गरेको थिए कि देयर आर सर्टेन केसेस, इट डिपेन्ड्स अन कर्व, इट डिपेन्ड्स अन सिचुएसन, कि तिमीको लिमिट अफ इन्टिग्रेसन हामीले आफै डिजायर्ड चुज गर्नुपर्छ. अदरवाइज यु मे फेस प्रब्लम, यु मे गेट रङ रिजल्ट. त तिमीको 0 to 0 भनेको त तिमीको स्टार्टिङ पोइन्ट पनि सेम भयो, एन्ड पोइन्ट पनि सेम भयो. त 0 देखि 0 को एरिया कसरी पोसिबल छ क्याल्कुलेट गर्न, हैन? Okay, so it comes 0 नै भयो. Okay, so that is the reason that you changed your limit of integration from pi to pi by 2. Okay, so 0 to infinity is now your limits of integration. Now you will proceed further on your own. यसपछिको step you will do on your own. Okay, can I leave it here?
Okay, ma'am.
Okay, next question. is somehow similar, but there is only one difference which makes it a slightly lengthy problem. Okay, you see we have same thing, but only denominator is different. We have denominator में square सा, okay, a square sin square x plus b square cos square x whole square, which was not present in the last previous one. Okay, so because we have some certain similarity in function, so definitely there will be certain similarity in the beginning. Beginning में हाम्रो same procedure छ. What are we going to do? We are going to eliminate this x from the numerator. Can you tell me after elimination of x eliminate भएपछि तिमीको expression मा के आउँछ होला? Can you tell me? Just take help from here.
2i equals integration of from 0 to pi 1 by a square sin square x plus b square cos square x whole square dx.
Yes, you forget pi, but very good trial. Okay, you after doing few steps, similar steps, you will get final expression as 2i equals 0 to pi times dx over a square sin square x. Okay, let me just simply copy this. Okay, where there is x, in place of x, you're going to get pi. Okay.
Yes, ma'am.
कसरी भयो? You see, let's realize it. हामीले अघि भर्खर के गरे थियो? सबभन्दा पहिला property number 4 apply गरे थियो. Wherever there is x, we replace it by pi minus x. So this was your expression. Pi minus x राखेपछि no change in denominator, numerator मा चाहिँ pi minus x. So you split it into two integrals. First integral मा numerator will be pi, second integral मा numerator will be x. Now this again becomes equal to I. So हाम्रो यो सबै steps similar भयो, only denominator is different. Denominator मा whole square छ, so it doesn't make much difference. So I goes there and you get 2i equals to 0 to pi, same expression with denominator my square. Okay, so this is your final expression. Now what? Same steps. You are now going to use property number 6 here also. If you don't change this limit of integration, you will face problem. Okay, so that is why here also we have to change limit of integration from 0 to pi to 0 to pi by 2. So we will do same steps. Okay, using property number 6 and so on. So we will be using property number 6 here also, because
Ma'am, how do we know that we should change the limits of integration?
यो केसमा तिमीहरूले प्रोसिड गर्दै गयो भने त तिमीले भर्खर रियलाइज गरेन के भयो, प्रब्लम के फेस भयो. अब इफ यु डोन्ट चेन्ज योर लिमिट्स अफ इन्टिग्रेसन यु विल डेफिनेटली फेस दिस ट्रबल. सो यो केसमा त मलाई त अलरेडी थाहा भएर मैले सुरुमै चेन्ज गर्न लगाएँ, तर तिमीहरूले त गर्दै गएपछि यु विल रियलाइज इट लेटर एन्ड एट दैट टाइम यु विल change your steps, you will include 1 or 2 steps, isn't it?
Yes, ma'am. त्यस्तो प्रब्लममा नजानको लागि चाहिँ अगाडि नै इन्टिग्रेसनको त्यो लिमिट चेन्ज गर्नुपर्छ भनेर चाहिँ कसरी थाहा पाउने के?
अब यो हामीले obviously practice makes man perfect हैन. हामीले प्र्याक्टिस गरिराख्यो भने त हामीलाई थाहा छ यो जुन यस्तो खालको प्रब्लम छ यसमा चाहिँ हामीले सब्स्टिट्युसन
यो टाइपको प्रब्लमलाई चाहिँ यसरी गर्ने भनेर
अघि हामीले भर्खर भन्यो न यो यस्तो प्रब्लम यस्तो सिचुएसन आयो भने when you have 1 over a square sin square x b square cos square x, तब तिमीलाई पहिलेदेखि थाहा थियो that you will multiply numerator and denominator by sec square x, then you will substitute n x equals to t. यो स्टेप्स तिमीलाई पहिलेदेखि थाहा थियो हो कि हैन? त्यही भएर तिमीले यहाँ अप्लाई गर्न पायो. In the same way when you will practice you will get to know that here of course we are going to, because हामीलाई 10x लाई t assume गर्न छ, त्यो केसमा चाहिँ हाम्रो 0 to pi भयो नि त हाम्रो limits of integration मा problem आउँछ. So you will change it in the beginning. Okay, that's how. Same here also. Same case here also. Okay, but there will be certain changes here. Okay, what is your function? Your function is a square sin square x over b square cos square x whole square. I know, hamra to ye cha whole square sir. So is it sufficient for us to multiply numerator and denominator by sec square x?
Sec power 4x.
Exactly. Okay, so you have to change this. You have to multiply numerator and denominator by sec to the power 4x, because sec square is x is not sufficient. Hamra यहाँ whole square sa thing bayra. Okay, what next? Let's go for next step. In your next step, you can say I equals 0 to pi by 2 sec to the power 4x dx over, what will be your denominator? A square tan square x plus b square whole square. You by multiplication by opposite. Now, do you know how to deal with this problem? Have you done this problem before? I think no.
Ma'am, full integral को square गर्ने हो.
Hello. What did you say?
सेक पावरफुललाई चाहिँ दुईटा सेक स्क्वायर एक्स बनाएर एउटालाई चाहिँ त्यो सेकलाई 10 तिर लैजाने, एउटाको चाहिँ त्यो dy तिरबाट गर्ने.
Full integral को square बनाएर पनि गर्न सकिन्छ ma'am.
Okay. Yes. What are you going to do here? Hamra substitution, again we have that same substitution method. Substitution ka lagi, as you have one of you already mentioned, यो जुन sec square sec to the power 4x है, यसलाई दुईटा पार्टमा डिवाइड गर्नु पर्यो. You're going to write it as एउटा sec square x लाई कसरी लेख्न मिल्छ? एउटा sec square x लाई के लेख्न मिल्यो? 1 plus tan square x.
1 plus 10.
एउटालाई चाहिँ हामीले 10 को कन्भर्जन गर्यो, अर्कोलाई चाहिँ as it is राख्यो sec square x. What is the reason? You will realize later. Okay, so sec to the power 4x can be written as sec square x into sec square x. So sec square x को ठाउँमा 1 plus tan square x. Now what will be your substitution in this case? Because your square छ हाम्रो square को कारणले what happens that your a tan x equals to bt is not going to work here. Simply bt लिएर तिमीहरुले solution आउँदैन. What are you going to do? You are going to substitute a, let a tan x equals to b tan theta. Okay, you take any other assumption, it is not going to work. Your assumption must be a tan x equals to b tan theta for this question. What next? Okay, so now simply find out, differentiate, find out your new limits of integration, and your process will be same now. So let's go for few more steps. A sec square x dx is going to be equal to b sec square theta d theta. Okay, now what next? Limits. Here also your limits of integration. What is your lower limit? 0. Okay, so what is tan 0 is 0, so theta also comes out to be equal to 0. So your lower limit is 0. Upper limit pi by 2, so you get tan pi by 2 infinity. Tan theta equals to infinity means theta equals
pi by 2.
Again pi by 2. Okay, what if it was pi? Tan pi is 0. You will get theta also equal to 0. So again your limits of integration could have been 0 to 0 if you don't change your limits of upper limit. Okay, so that is the reason here also you had to change your limit of integration from 0 to pi to 0 to pi by 2. So limits of integration remains as it is, 0 to pi by 2 ne roya. Okay, so what is your new integral? Your new integral will be I छ हैन 2 cancel out भइसक्यो. Okay, so I equals 0 to pi by 2. We have changed this n to this expression a 1 plus 10 square x. So 10 square x को ठाउँमा के राख्ने? A 10x is equals to b 10 theta implies what is your 10 square x? के आउने भयो 10 square x को ठाउँमा? b square upon a square 10 square theta, isn't it? Okay, so your numerator becomes 1 plus b square. यो जुन 10x छ 10 square x छ त्यसको ठाउँमा के आउने भयो 10 square x को ठाउँमा b square over a square 10 square theta. Next, sec square x छ नि sec square x dx. You have sec square x dx. So what is sec square x dx? b by a, b upon a, sec square theta d theta. Okay, so multiply this expression by b upon a, sec square theta d theta. All right. Now denominator part. What is your denominator? Your denominator is a square 10 square x plus b square. So a square 10 square x को ठाउँमा के आउने भयो? B square, what is it? Look here. According to your substitution, a square 10 square x will be equal to b square 10 square theta. Okay, so let's do that. So you will get a square 10 square, sorry, b square 10 square theta plus b square and whole square. All right. So you can take b to the power 4 outside. Now let's simplify this expression. अब चाहिँ हाम्रो खासै के काम बाँकी मात्रै रह्यो simplify गर्ने expression लाई, and then you will get simple expression and you can easily integrate. Okay. अब चाहिँ हाम्रो
यसमा त हामीले 10x = tan theta मात्र लेट गरेर नि हुँदैन जस्तो छ है.
हुँदैन यो हाम्रो एक्सप्रेसन चेन्ज हुँदैन नि त्यही भएर
हुन्छ नि.
Ma'am, pi is missing in the numerator.
What is missing? Pi? Oh yes. Pi is always there. Pi misplaced by the. Pi is there. Okay. Pi is there. Pi. So what next? Let's just simply look at this expression and now go for solution. Let's simplify matre garum hai aba. So what next? So pi over. Let's take all the constants outside. Sabhi constant la bahar liera jam hai ke huncha. Let's see. First expression. First expression ma timako yo bata ke aayo b square over a square common liu. Okay, so you will take LCM first. Your a square like LCM linear, you will get a square plus b square 10 square theta upon a square. So you are going to take only a square outside. You know, a square matre bahira gaya. So pi over a square, and then b upon a. Next expression bata b upon a. So from next expression you will get b over a. And from denominator, you will get b square whole square. So you will get multiply by 1 by b to the power 4. So we have taken all the constants outside. So what is left? What is left with us? Here, this expression. This expression में क्या बाकी रहा? A square plus b square 10 square theta. Here sec square theta. Next sec square theta d theta over b common gaisake you will get 10 square theta plus 1 whole square, which is Can we write it as sec square theta into sec square theta? Denominator part, can we write it like this way? You will get 1 plus tan square theta, which is sec square theta whole square. So sec square theta into sec square theta. So this sec square theta gets cancelled. You cancel out by and you get a square over sec square theta plus b square tan square theta over sec square theta. What is it? You will get यहाँ तिमीको के आयो? This whole expression will give you a pi over a cube b cube. You will get pi upon a cube b cube 0 to pi by 2. You will get a square sec square theta. Sorry, a square cos square theta. Right? You have a square upon sec square theta, which is a square into cos square theta plus what is tan square theta over sec square theta?
sin square theta.
Exactly. D theta. Can you now integrate this function?
Yes,
Sin
ma'am.
square theta को integration सकिन्छ, cos square theta को integration सकिन्छ. How do you change this expression to integrate?
1 plus cos 2 theta by 2.
Very good. You can write cos square theta as 1 plus cos 2 theta by 2. And what about this?
1 minus.
Exactly, 1 plus cos 2 theta by 2. Cos 2 theta by 2. Now you can easily integrate. अब integration गर्दाखेरि 1 को integration cos 2 theta को integration मात्रै गर्नु बाँकी रह्यो. Okay, so from this expression you can do it on your own and your final result must be. Have you got your books? I assume yes. You are referring to books, isn't it? Pi square. तिमीको pi square आउनु पर्यो solution मा a square plus b square. Now within few steps you will get this result. 4 over a cube b cube. Okay. So that's all for today. Any doubt anywhere? Any steps you want me to explain again? Yes. Let me download attendance. If any day, if I forget to download attendance, you all, any one of you can remind me. Okay? Very important.
Yes, ma'am.
कि मेरे स्क्रीन देखिए ना अक्षिता you were the only one who was facing
Yes, ma'am, मैले देखियो.
अरूहरुले पनि प्रब्लम भएको थियो?
थिएन म्याम.
Okay, so अक्षिता तिम्रो साइडमा प्रब्लम भएर रहेछ है? Okay, so everything is clear. So we will start new topic next time, improper integral. Okay, integral as a limit of sum. Especially if you have got if you have the following your textbook, then you can see that right after this exercise you have another exercise which is not in your course. Okay, integration as a limit of sum is not in your course. Keep this in mind. तिमीको पहिला चाहिँ थियो कोर्समा, but तिमीको course revise भइसकेपछि this part was eliminated. Okay, so keep this in mind. Now next time we will be starting with improper integral. All right, that's all for today. Bye bye for now. तिमीको पनि क्लासेसमा के इन्फेक्सन धेरै स्टुडेन्ट्सलाई प्रब्लम भइरहेछ त्यस्तो के छ? I can see we have 46 students, so I think most of you don't have any problem. सेकेन्ड इयरको क्लासेसहरु त सबैले कल गर्दै क्यान्सल गर्न लागेको छ. That's why.
Ma'am.
Yes, विशाल.
यो बुकमा भएको लिमिट अफ सम भन्नेवाला छैन अहिले?
कोर्समा छैन.
ए
Okay. Okay, bye bye for now.
म्याम अनि योभन्दा अगाडि पनि त्यो इन्टिग्रेसनको दुईटा एक्सर्साइज छ नि त्यस पनि छैन म्याम
त्यो त तिमीको प्र्याक्टिसको लागि हो तिमीको एक्चुअल कोर्स नै प्रोपर्टिज अफ डेफिनेट इन्टिग्रलबाट सुरु छ जुन कोर्समा तिमीको कोर्समा जे कुरा छ त्यो कुरा हामीले कहिले मिस वी आर नट गोइङ टु मिस इट आउट ओके
ओके म्याम थ्याङ्क यू म्याम
सुरुको दुईटाबाट एक्जाममा आउँदैन म्याम
त्यो दुईटा तिमीको त्यो दुईटा एक्सर्साइज आउँछ भने त तिमीले फर्दर इन्टिग्रेसन गर्न सक्छ नि जस्तो हाम्रो प्रोपर्टिज अफ डेफिनेट इन्टिग्रलमा पनि हामीले भर्खर प्रिभियस तिमीले पढिरहेकै मेथड्सहरू पनि अप्लाई गर्यो नि त्यही भएर तिमीको रिभिजन एज अ पार्ट अफ रिभिजन इज देयर ओके द्याट वाज फर योर रिभिजन तिमीको एक्जाममै त तिमीको सोध्नु पर्यो नि डेफिनेट इन्टिग्रल भन्दा अगाडिबाट सोध्छ बट त्यो पोर्सन पनि कहीँ न कहीँ त युज भयो नि वी क्यान नट एक्ज्याक्टली से द्याट इट इज इक्जाममा सोध्दैन भनेर एक्ज्याक्टली त भन्न मिलेन इक्जाममा युज हुनसक्छ ओके आउनु पर्यो आफूलाई प्र्याक्टिस गर्ने तिमीको जुन 11-12मा स्ट्यान्डर्ड क्वेसन्सहरू जुन तिमीले गरेको छ त्यही नै छ नि तिमीको जस्ट लुक एट इट एउटा इन्डेफिनेटको लागि भयो एउटा डेफिनेट इन्टिग्रलको लागि भयो ओके सो आइम गोइङ टु लिभ नाउ एनी अदर क्वेरिज
No, ma'am.
Okay.